Hello everyone, welcome back to the PACE Academy. In today's session, we will discuss the most important topic, electrochemistry, right? So here, first we will discuss introduction of this topic. So here, nowadays, everyone is using mobile, right? So here, if we look at the mobile, that mobile runs depending on battery, right? So here, what is this? This is battery, right? Is mobile phone runs without a battery? Is mobile phone run without a battery? Definitely no, right? So here, how this works? How this phone works with the help of battery. So now, the working principle of this battery is mainly explained by this chapter, electrochemistry. So in this chapter, we will discuss how the battery works, on which principle it works. Okay. So now, if we look at the electrochemistry, what is electrochemistry? It is the study of production of electricity from energy released during spontaneous chemical reactions. So here, whenever spontaneous chemical reactions run, so when the chemical reactions carried out, it releases some energy. So if we convert that energy into the electrical energy, right? So how that electrical energy produced from energy which is released during the spontaneous chemical reactions. Okay, so that will be studied here in this chapter, electrochemistry. And not only the production of electrical energy from chemical energy, the use of electrical energy to bring about chemical transformations, including non-spontaneous processes. So the chemical energy converted into electrical energy, and by using that electrical energy, even chemical transformations can also occur. So to study the production of electricity from energy released during chemical reactions and the use of electrical energy to bring about chemical transformations, those including non-spontaneous reactions. So here, first, what are the spontaneous and what are the non-spontaneous reactions? Spontaneous reactions means the reactions which carried out on their own. They won't require any external force on them. Okay, so they themselves carried out. They do not require any external force to carry out. So those reactions are called spontaneous chemical reactions. Okay, so from that spontaneous chemical reaction, some energy released. If we convert that energy into chemical energy, how this happens? And again, by using that electrical energy, we are carrying out non-spontaneous chemical reactions. What is the meaning of non-spontaneous? Non-spontaneous means they are not carried out on themselves. They required external energy. So here, what is that external energy? That is electricity. Okay. So the use of electrical energy to bring about chemical transformations, including non-spontaneous reactions. Okay, so non-spontaneous means they do not carry it out themselves, so they required external energy. What is that external energy here? Electrical energy. The best example here is charging of battery, discharging of battery. So here, for example, if we look at the battery, okay, mobile phone. So first, what we are doing, if it is totally discharged, we are charging that mobile phone, right? So here we are plugging and we put the charging. That means what happens here? The electrical energy is converting into the chemical energy which is stored in the battery. Okay, so the electrical energy is converting into the chemical energy here. So the transformation of electrical energy into chemical energy. So here, the charging of battery is non-spontaneous. Okay, so that's why for the charging of battery it required external electrical energy. So here we are carrying out chemical transformation by using electrical energy. Now after the phone completely charged, what we are doing? We are removing that plug and we are using the mobile. So while we are using the mobile, it discharged. For discharging, is it required any external energy? No, it doesn't require any external force to discharge. So that is spontaneous process. That is spontaneous process. So here in this spontaneous process, what is happening? Chemical energy is converting into electrical energy to run that phone. Okay, so here how that chemical energy is converting into electrical energy, how the electrical energy is converting into chemical energy. So all these we are studied in this chapter. Okay, so that study of production of electricity from energy released during spontaneous reactions and the use of electrical energy to bring about chemical transformations including non-spontaneous process is called electrochemistry. Electricity, chemistry, the energy related to the chemical reaction. So together it is called electrochemistry. Okay, next. Here if we look at in this picture, this is the chemical energy, means the energy released from the chemicals. Now we are converting this chemical energy into electrical energy. Okay, next, here batteries and fuel cells. Just now we discussed batteries and fuel cells convert chemical energy into electrical energy. That energy is used in the running of that apparatus, right? Next, so here these batteries are used in mobile phones and these fuel cells are generally used in vehicles. So here these converts the chemical energy into electrical energy. Electrochemistry is important for creating new technologies that are eco-friendly. Why? Because of more efficiency and less pollutant. They are more efficient and less pollutant. So we know that nowadays we are facing global warming issue, right? So that is to at least reduce the global warming or the effects of those, we should use the things which are eco-friendly. We should use things which are eco-friendly. So here in that electrochemistry is important. In that way electrochemistry is important for creating new technologies which are eco-friendly. Why? Because these are of more efficient and they are less pollutant. They are less pollutant, more efficient, so that's why they are eco-friendly. Okay, so here electrochemistry is important to produce such technologies which are eco-friendly. Next, electrochemical cells. So what are the electrochemical cells? So here, as name suggesting, electrochemical cell is a device which converts chemical energy from spontaneous redox reactions into electrical energy. So here what are the electrochemical cells? Electrochemical cells are the devices which converts chemical energy from spontaneous reactions into electrical energy is called electrochemical cell. Okay, so here electrochemical cell is a device which converts chemical energy into electrical energy. Okay, simply it is a device which converts chemical energy into electrical energy. So which chemical energy? The energy from spontaneous redox reactions. Redox reactions. Already we learnt in the 10th class what are those redox reactions. Right? So redox means the reaction which involves both reduction as well as oxidation. Those are called redox reactions. So the energy which released during spontaneous redox reactions is converted into electrical energy by this device. Okay, next, these are also called as galvanic or voltaic cells. These electrochemical cells are also called as galvanic or voltaic cells. See here, this is the galvanic cell. Generally it is called Daniell cell. Okay, Daniell cell is the best example for galvanic cell. Next, in this device, the Gibbs energy of the spontaneous redox reactions is converted into electrical energy. So here, generally Gibbs energy is a product of standard potential and the total current carried by those electrons. So here, for spontaneous reactions, generally Gibbs energy is always negative. For spontaneous reactions, Gibbs energy is always negative, right? So here, in this in this galvanic cell, the Gibbs energy of the spontaneous redox reactions is converted into electrical energy. That is, Gibbs energy is shown by delta G. So delta G is equals to minus of NFE. Okay, here delta G is always negative for spontaneous reactions. For non-spontaneous, it is positive. Okay, so delta G is equals to minus of NFE. So here, what is delta G? Delta G is the Gibbs energy, Gibbs free energy, and what is N? Moles of electrons, number of moles of electrons, and what is F? Faraday's constant. Here, N into F gives us the total charge carried by them, right? And what is E? Standard potential, standard cell potential. So the product of total charge carried by them and standard cell potential gives us Gibbs free energy, delta G. Okay, so in this electrochemical cell, this total energy converted into electrical energy. Next, what are the uses where we are using these cells? So generally these cells are used for running a motor or other electrical gadgets like heater. So here this is the heater which is used by electricity. Next, fan and geysers, etc. Okay, so these motors or other electrical gadgets are running by electrochemical cells. So electrochemical cells used for running a motor or other electrical gadgets like this. Next, description. Daniell cell is an example of galvanic cell. So what is the cell reaction for this Daniell cell? Zinc plus copper plus 2. So here this is the reaction of the Daniell cell. Okay, so remember this cell, zinc is reacting with copper plus 2 and giving zinc plus 2 and copper. Actually this cell reaction is the combination of two half cells. What are those two half cells? First look at here, zinc is converting into zinc plus 2, zinc converting into zinc plus 2. So here this reaction is called what? Oxidation reaction. This reaction is called oxidation. Why? Zinc is converting into zinc plus 2. So this half reaction will take place in one cell. Next, copper plus 2 is converting into copper. So how copper plus 2 converts to copper? By gaining 2 electrons. So copper plus 2 by taking 2 electrons converts to copper. So gain of electrons is called reduction, right? Gain of electrons is called reduction. Here how zinc is converting into zinc plus 2? By losing 2 electrons. So the loss of electrons is called oxidation. Gain of electrons is called reduction. So here in this total reaction, both oxidation and reduction takes place. That's why this is called redox reaction. In this reaction, the energy released, okay, that energy is converted into electrical energy. So here now this oxidation half cell will take place in one part of the galvanic cell, and this reduction reaction will take place in another part. Okay, so where they will take place and how it will works, we will see in the next step. Next, these reactions occur in two different portions of the Daniell cell. Okay, it has a two different portions. One is left side, one is right side. The reduction half reaction occurs on the copper electrode, while the oxidation half reaction occurs on the zinc electrode. Already we discussed this, right? So zinc is converting into zinc plus 2, that is oxidation reaction. So oxidation half reaction occurs on zinc electrode and reduction half reaction takes place on the copper electrode, and these two cells are called half cells. Okay, oxidation and reduction cells are called half cells, are together called redox couples. Each half cell consists of a metal rod. Each half cell consists of a metal rod which is dipped in an electrolyte. See here, if we look at this Daniell cell, in this there are two half cells, right? So this is one portion and this is one portion. So in the left hand side portion, the zinc electrode, this is zinc electrode. Zinc electrode is dipped in an electrolyte, for example zinc sulfate or zinc nitrate. You can take zinc sulfate or zinc nitrate, that is of that electrode's electrolyte. Okay, next here copper electrode. In this portion, copper electrode dipped in electrolyte of copper itself. Electrolyte, that should be electrolyte of that copper. Okay, so here you can take copper sulfate or you can take copper nitrate. You can take any one. Okay, so here now we dipped. Each half cell consists of a metal rod which is dipped into an electrolyte. Okay, next, these two electrodes are connected through the electrical wire, voltmeter and switch. This is switch. Okay, why we required voltmeter? To find out the potential difference between two cells. Okay, next, here to continue this circuit we are using salt bridge. So what is this here? This is salt bridge. Salt bridge actually completes the circuit and it stops the accumulation of oppositely charged ions in that cells. Okay, so that's why we are using salt bridge in this. Okay, this salt bridge contains like sodium chloride or sodium nitrate. We can take any one, sodium chloride or sodium nitrate. Now we will look at here. This is the copper electrode, that is zinc electrode. Next, the two half cells are connected by a metallic wire through a voltmeter and switch externally. So what is this device? Voltmeter. Why we are using voltmeter? To find out the potential difference in that cell. Next, switch, to switch off and switch on the circuit. Next, the electrolytes of the two half cells are connected internally. They are connected externally by voltmeter, switch and electrical wire. And these two electrolytes connected internally by a salt bridge. Okay. Next, reduction half reaction is copper plus 2 electrons, that gives copper, and oxidation half reaction is zinc, giving zinc plus 2 electrons. So this is the arrangement of galvanic cell. Next, what are the two reactions takes place here? Oxidation and reduction. Reduction takes place on the copper electrode and oxidation on the zinc. So here first copper plus 2 will take 2 electrons and gives copper, and in the oxidation half reaction zinc is converting into zinc plus 2 by losing 2 electrons. Okay, next how it works, how this electrochemical cell works. Now we will see the working process of this. There is a tendency of metal ions from the solution to get deposit on the metal electrode, trying to make it positively charged. At the same time, metal atoms of the electrode have a tendency to get into the solution and make it negatively charged. At equilibrium, there is a separation of these two types of charges. Hence, depending on the tendency of two opposite reactions, the electrode may be positively charged or negatively charged with respect to the solution. So here now I hope most of you not understand this cell, right? So now I will try to explain in a simple way. First, what we are taking here, zinc electrode. What we are taking, zinc electrode. We know that zinc electrode always try to lose 2 electrons. Why? After losing 2 electrons from the valency shell, it will get completely filled shells. So that's why it will get the stability. That's why what zinc will do, always it try to lose 2 electrons. Okay, so now by losing the 2 electrons, it converts into zinc plus 2 ion. Now that electrons which are released from the zinc plus 2, when we connect this zinc electrode to the electrical wire, the electrons which is released from this zinc plus 2 will pass through this electrical wire and enters into another portion. Okay, another portion of the cell, electrochemical cell. So now what we are saying here, zinc by losing 2 electrons converting into zinc plus 2, right? Zinc by losing 2 electrons, it is converting into zinc plus 2 electrons. So here these 2 electrons are with the help of electrical wire passing into another portion. Then what about the zinc plus 2? Zinc plus 2 cannot will be on the surface of zinc. So that's why to accommodate these zinc plus 2 ions, we are taking zinc sulfate solution here, electrolyte of same electrode, electrolyte of zinc. Why we are taking electrolyte here? Just to accommodate this zinc plus 2 ions. Okay, so now here we are taking zinc sulfate for example. So ZnSO4, ZnSO4. So now we know that when we dissolve the zinc sulfate in the water, it ionized into zinc plus 2 SO4 minus 2. So zinc plus 2 SO4 minus 2. Now already that electrolyte contains equal number of Zn plus 2 SO4 minus 2. Again from this zinc electrode, zinc plus 2 ions are coming out and they are entering into this solution. Okay, so now zinc plus 2 ions are coming from that metal electrode, metal rod. We are taken here zinc metal rod, right? So from that metal rod we are getting more number of zinc plus 2 ions. So now that zinc plus 2 ions are entering into this solution. Okay, so now look at here, there are very few number of sulfate ions. There are very few number of sulfate ions, but look at many number of zinc plus 2 ions. So what is happening? The number of positively charged ions are increasing here and sulfate ions are decreasing. Now if we look at here, the electrons are entering into this solution. Now in this what we are taking here? Copper sulfate. Okay, now so here we know that Generally copper sulfate is when dissolved in water ionized into Cu plus 2 SO4 minus 2. Now here whenever the electrons are entered into this electrolyte solution, that copper plus 2 ions accepts that electrons. In general, Cu plus 2 are readily accepts that electrons to get the stability. So that's why here this copper plus 2 ions will take that electrons and convert into the copper. So the copper plus 2 ions which are present in the electrolyte will gain 2 electrons from this and converts into copper. They converts into copper. So here copper, which is in neutral state, cannot be in the electrolyte solution. So to accommodate this copper metal, we are taking here copper electrode. So what we are taking here? Copper electrode. Why we are taking copper electrode? To accommodate this copper metal, we are taking copper electrode. So now this copper will deposit on the surface of copper electrode which we are taken. So now the number of copper plus 2 ions from electrolyte will continuously decrease. Why? Because that copper plus 2 are absorbing that electrons and converting into copper, and they are deposited on the surface of the copper metal. So now if the number of copper plus 2 ions are decreasing, then which number will increase in the solution? Negatively charged ions will increase in the solution. Okay, SO4 minus 2. What about the copper plus 2? They are gaining the 2 electrons and keep on depositing on the metal surface. Okay, so if we carry out this process for some time, what happens? Actually here zinc from this metal rod converting into zinc plus 2 and 2 electrons. That zinc plus 2 entering into the electrolyte solution and electrons are flowing into this one. Okay, so here if you take voltmeter here, you can see the value here. This is a zinc electrode, right? So you will see 0.76 potential in that voltmeter. Okay, and so here if you connect even bulb to this wire, this will glow. Why it will glow? Because the electrons are flowing from left side to right side, and whenever electrons entered into this electrolyte solution, the copper plus 2 ions will take that electrons and deposits on the surface. Now the number of SO4 minus 2 ions will increase in this portion, zinc plus 2 ions will increase in this portion. This electrolyte solution becomes positive. Here this electrolyte solution becomes negative. So if the number of ions are keep on increasing, what happens? Here the charge equilibrium will affect. So to maintain that equilibrium, what we are doing here without breaking, if the electricity should pass continuously, we should decrease the number of positively charged ions here and the number of negatively charged ions here. So to decrease the number of negatively charged ions here, number of positive charged ions here, what we are doing? We are connecting these two solutions with the salt bridge. So why we are connecting these two electrolyte solutions with the salt bridge? Only to maintain equilibrium between two solutions. To maintain the equal number of ions, we are taking salt bridge. How this salt bridge works here? Generally, this salt bridge contains sodium chloride, Na plus Cl minus. So here this salt bridge is closed with the two ends. The two ends of the salt bridge is closed with the cotton buds. Okay, so from that only Cl minus ions entered into this solution. Cl minus ions entered into this. Why only Cl minus? Because this side zinc plus 2 ions concentration is more. So to balance the zinc plus 2, only Cl minus ions will move this side. Okay, so negatively charged ions will move this side, and here this side sulfate ions number will more. So that's why Na plus ions will comes this side. So this salt bridge continuous, it supports the continuous movements of ions. So that's why the circuit is closed and continuously it produces electricity here. If there is no salt bridge, the accumulation of oppositely charged ions will increase, and after some time it may stop the flow of electrons. So to continuously flow the electrons, we are connecting these two electrolytes with the salt bridge. Okay, so salt bridge, it allows the continuous flow of electrons. Okay, so here from this salt bridge, oppositely charged ions, Cl minus ions will come here, and Cl minus ions will neutralize these positively charged ions, and here Na plus ions will come and it will neutralize the sulfate ions. So here the number of oppositely charged ions are generally equals to the zinc ions which are coming from that electrode. Okay, so now here if you clearly observe this process, the zinc rod which we are taken is continuously become thin. Why? The zinc is converting into zinc plus 2, right? So it become thin, and this side that copper electrode become fat. Why? Because from the solution more number of copper plus 2 ions turns into copper metal and deposits on the surface. So that's why here metal electrode become thick, here zinc electrode become thin. Okay, so this is the working principle of this Daniell cell. Okay, I hope everyone understands this concept. Next, so what happened here? Whenever the zinc electrode converting into zinc plus 2 and electrons, and in the right hand side portion the copper plus 2 is converting into copper, there is the development of potential difference. So a potential difference developed between the electrode and electrolyte solution is called electrode potential. If there is electrode potential, then only electrons will move from one portion to another portion. Already we know that in a circuit, when current passes, whenever there is some potential difference, if there is potential difference, then only electricity passes. So here also a potential difference developed between electrode and electrolytic solution. In a galvanic cell, the oxidation half cell is called anode and it has negative potential with respect to the solution, whereas the reduction half cell is called cathode and it has positive potential with respect to the solution. So what we said here, we have taken left hand side zinc sulfate electrolyte, and in this we dip zinc electrode, right? And in the right hand side we have taken copper sulfate solution, and in that we dip copper electrode, and these two are connected externally to the voltmeter and switch. So at this left hand side, in a galvanic cell, left hand side cell is called oxidation half cell. What is this called? Oxidation half cell. This is oxidation half cell and it is reduction half cell. Reduction half cell. And oxidation half cell is called what? Anode. This is called anode. And reduction half cell, it is called cathode. This is cathode. So here at anode, what is happening? Oxidation reaction. That means the zinc electrode, the zinc metal by losing 2 electrons, converting into zinc plus 2 electrons. So here at this oxidation half cell, oxidation reaction is happening. That's why this half cell is called oxidation half cell. So what is that oxidation reaction? Zinc is converting into zinc plus 2 electrons. So here at this anode, negative potential with respect to the solution. Okay, so in this oxidation half cell, generally it generates negative potential with respect to the solution, whereas reduction half cell is called cathode and it has positive potential. It has negative potential. Electrons are entering into this, right? So here it has a negative potential. The electrons are released here. The number of electrons are more. So that's why it has which potential? Negative potential. Next, here generally which ions it has? Copper plus 2. Okay, so now this has positive potential. It has which potential? Positive potential. It has positive and it has negative potential. And here the electrons are entering from this electrode through the electrical wire into this half cell. Here copper plus 2 taking the 2 electrons, copper plus 2 gaining the 2 electrons and converting into copper. So copper plus 2 gaining 2 electrons and converting into copper. This reaction is reduction reaction. So that's why this half cell is called reduction half cell. This is reduction half cell and this is oxidation half cell. In this oxidation reaction, the number of electrons are more. At this electrode, the number of electrons are more. So that's why it has negative potential. And here it has positive potential. Why? Because the number of copper plus 2 ions more. They are taking 2 electrons and converting into copper. So that's why it has positive potential. It has negative potential. Okay, next. This anode is generally having positive charge. So at this, what is happening? Zinc is converting into zinc plus 2. Okay, next here copper plus 2 is converting into copper. It has negative potential, it has positive potential. There is difference in the potential. So that's why the electricity is passing. Okay, next here if we look at this, first one anode. Okay, next it is cathode. So at this anode, which potential is generated? Negative potential, because oppositely charged ions are reaching the surface. Here positively charged ions. So from here to here, what is that? Diffuse layer. The ions are diffusing, moving. Why? Negatively charged particles are moving towards the electrode and negatively charged particles. So negatively charged particles moving are attracting towards the electrode. Why? Because zinc is converting into zinc plus 2. So here zinc plus 2 attracting negatively charged ions. So that's why it is negatively potential. Okay, next here the electrons are entering into this electrode. So the number of electrons are increasing. So that electrons are attracting copper plus 2 ions. So copper plus 2 ions are moving towards the electrode. Okay, oppositely charged ions are reaching the surface of electrode. They are negatively charged, here positively charged. So opposite charged ions are adjacent to the surface. So here between electrode and electrolyte, negatively charged particles are more. So it has negative potential and here it is having positive potential. This is about the Daniell cell. Okay, so here we can take even zinc nitrate also. Instead of zinc sulfate, we can take zinc nitrate solution, but that must be electrolyte of zinc, and here this electrolyte must be the salt of copper. Okay, so copper nitrate, or you can take copper sulfate. Next, which one we dipped in zinc nitrate? Zinc anode. And here from this zinc, what is happening? Electrons are releasing. Okay. Next, here it is copper cathode, and it is having which potential? Positive potential. Next, whenever we dissolve zinc nitrate in the water, it gives zinc plus 2 and nitrate ions. And here copper nitrate ionized into copper plus 2 and nitrate ions. Next, here these two electrolytes are connected internally with the salt bridge. Salt bridge contained here sodium nitrate. Next, so here this zinc electrode is converting into zinc plus 2 and electrons. So from this zinc electrode, zinc plus 2 ions are entering into solution. Next, in this copper plus 2 are moving towards the electrode. Now zinc plus 2, from zinc plus 2 the electrons are released, and that electrons are entering into this half cell. Now, so here these electrons are gained by copper plus 2 and converting into copper. Now here the number of zinc plus 2 ions increases. So to balance that zinc plus 2, nitrate ions from this sodium nitrate, Na plus NO3 minus ions will come. So that NO3 minus ions are entering into this solution. Why? Because here the number of positively charged ions are more. So that's why NO3 minus entered into this side and Na plus will move this side. Why? Because copper plus 2 are converting into copper and depositing on the electrode. So which concentration will increase here? Nitrate ions. So to balance this nitrate ion, Na plus will move this side. Okay. So this is about the Daniell cell. Next, number of galvanic cells can be constructed on the same pattern of Daniell cell by taking combinations of any two different half cells, not only zinc and copper. We can combine any two different half cells. Okay, so number of galvanic cell can be constructed on the same pattern of this Daniell cell by taking combination of different half cells like zinc and copper and zinc and iron, or you can take silver and copper, like that. Okay, so by taking two different half cells combination, we can construct number of galvanic cells. Now we will discuss some multiple choice questions on this topic. Okay, first, a cell in which electric current is produced by an oxidation reduction process is called. A cell in which electric current is produced by an oxidation reduction process means redox process, that is called which cell? Galvanic cell, or it is also called voltaic cell. We will see the options: voltaic cell, reversible cell, concentration cell, standard cell. That is voltaic cell or galvanic cell. So option A. Next, the function of salt bridge in an electrochemical cell is, options are: to prevent the mixing of the electrolyte in two half cells, to complete the circuit, and to maintain the electrical neutrality of the two half cells. See here, all these three are the functions of salt bridge, all the above. So here actually we are not taking the two half cells in one, right? So this salt bridge prevent the mixing of two electrolytes. Next, it completes the circuit and it maintains the electrical neutrality of the two half cells. So all these three are the functions of salt bridge. Next, Daniell cell is shown as zinc plus 2, copper plus 2. Next, zinc plus 2, copper plus 2, copper plus 2, zinc plus 2, zinc, and Cu plus 2, Cu, zinc plus 2, zinc. So here first what we said, in the left hand side half cell, that is oxidation half cell, zinc is converted into zinc plus 2 electrons. Okay, next in the right hand side what happened? Copper plus 2 gained these 2 electrons which are lost by zinc and converted to copper. Okay, so we are writing a cell reaction by combining these two. How? Zinc first converting into zinc plus 2, right? Zinc is converting into zinc plus 2. Next, in the second half cell what is happening? Copper plus 2 is converting into copper. Okay, so now this zinc is the actually electrode and zinc plus 2 is present in the electrolyte solution. So electrode and electrolyte solution are separated by a single line, and here copper plus 2 is in electrolyte solution and copper is on the electrode, right? Now this electrolyte and electrode are separated by one single line. Now these two half cells are separated by salt bridge. Here salt bridge is shown by the two vertical lines. Okay, so now this is a representation of Daniell cell. Here zinc is in which state? Solid state. It is electrode, zinc rod, right? So solid state. Zinc plus 2 is in electrolyte. It is in which state? Aqueous state. And here copper plus 2 is in aqueous state and copper is in solid state. So now this is the representation of Daniell cell. Okay, and remember in the left hand side half cell we must show oxidation. Zinc is converting into zinc plus 2, oxidation. Here copper plus 2 is converting into copper, reduction. Here it is the reduction process and here it is oxidation process. Oxidation takes place at oxidation half cell, that is left hand side cell, and reduction takes place at the right hand side cell. Okay. Next, so which is the correct one here? Zinc plus 2, but here also copper plus 2, oxidation. So this is not the correct. Next, look at here, zinc converted into zinc plus 2, oxidation, and copper plus 2 converted into copper, reduction. So this is the correct answer. Okay, so which is the correct option? B. Next, now we will see how we are representing that Daniell cell, that is based on IUPAC convention. Okay, so we will see IUPAC convention of this Daniell cell. IUPAC convention. What is the full form of IUPAC? International Union of Pure and Applied Chemistry. Write the anode on the left hand side and the cathode on the right hand side. Left hand side anode half cell reaction and right hand side cathode half cell reaction by putting a vertical line in between the symbol of the metal and formula of the electrolyte in the solution, and put a double vertical line in between the two solutions. Put double vertical line. Here double vertical line indicating salt bridge. Okay, in the solutions, that is for example like this, anode, cathode. So here anode left hand side, cathode right hand side. So in between anode and cathode we should write double vertical line. Next, so if we take anode, at the anode what is happening? Metal which is on electrode converting into ion, that is entering into electrolyte, right? For example, if we take the zinc is converting into zinc plus 2. So this is the reactant, this is the product. Where is that product? It is entering into electrolyte. So now that metal, electrolyte, reactant, product are separated by one single vertical line. Next, here electrons are entering into the right hand side cathode portion, and here that electrons are gained by electrolyte ion. What is that? Copper plus 2. Now copper plus 2 is converting into copper, and which is deposited on the metal surface. So here in the right hand side portion copper plus 2 is converting into copper. So this is the reduction. Okay, and this is oxidation. So now this is happening at anode and this is happening at cathode. So anode and cathode both are separated by salt bridge. So write the anode on the left hand side and the cathode reaction on the right hand side by putting a vertical line in between symbol of the metal and formula of the electrolyte. Next, put a double vertical line in between the two different solutions. Okay, so that is the anode one and this is the cathode. We are writing two vertical lines. Next, what is R? Reactant. What is P? Product. Next, for example, cell reaction, zinc plus copper plus 2 is giving copper plus 2 plus Cu. So here already we discussed in the Daniel cell, right? So what is happening? Zinc is generally converting into zinc plus 2. Reactant product. From zinc which is coming out? Electrons. That electrons are gained by copper plus 2. So here zinc and copper plus 2 are the reactants. Now zinc is converting into zinc plus 2 by losing 2 electrons. That 2 electrons are gained by copper plus 2. So that's why it is also reactant. Now copper plus 2 is giving copper. So zinc and copper plus 2 are the reactants and zinc plus 2 and copper are the products. Simply here we are mixing two half reactions. Left hand side, zinc is converting into zinc plus 2 electrons. Okay, next right hand side, copper plus 2 is taking the 2 electrons and converting into copper. So here the electrons which are released by zinc are gained by copper plus 2. So these 2 electrons will get cancelled. Next, so what are the reactants here? Zinc and copper plus 2. And what are the products here? Zinc plus 2 plus copper. So these are the reactants, these are the products. Okay, so here zinc, copper plus 2, zinc plus 2, copper. And what is the zinc here? Zinc electrode, that is in which state? Solid state. Next, what is copper plus 2? Copper plus 2 is coming from electrolyte solution. So electrolyte solution is aqueous solution. So that's why AQ. Now from this zinc which is coming out, zinc plus 2. That zinc plus 2 finally getting into the aqueous solution. So aqueous. Next, the formed copper is in solid state, that is getting deposited on the metal surface. So that's why it is in solid state. Okay, so this is about the cell reaction. Now how to represent the cell? Okay, cell representation. Cell representation is zinc converting into zinc plus 2 and copper plus 2 is converting into copper. So this zinc and zinc plus 2 separated by single line and copper plus 2 copper is converted by single line. Now these two solutions are separated by two vertical lines. Next question. Write the cell reaction taking place in the cell. Can you write this? Cell reaction. He is asking cell reaction. He given the cell. First, what is the reactant here? Copper. Copper is converting into copper plus 2. How copper converted to copper plus 2? By losing 2 electrons. So here by losing 2 electrons, copper is converting into copper plus 2, right? Next, how Ag plus converts to Ag? So here reduction. By losing 1 electron, it converted to Ag. So here Ag plus gains 1 electron and converts to Ag. But here copper lost how many electrons? 2 electrons. So to get cancel these 2 electrons, we should take 2 silver plus ions. 1 Ag plus takes 1 electron. But here copper, 1 copper losing 2 electrons. So if we take that 2 electrons, that 2 electrons can be accepted by 2 silver plus. Why? Because 1 electron accepted by 1 Ag plus and second electron accepted by second Ag plus. So that's why we are taking 2 Ag plus. Now the 2 Ag plus are taking 2 electrons and giving 2 Ag. Okay, so now 2 electrons will get cancelled and write Cu plus 2 Ag plus gives, what are the two products? Cu plus 2 plus 2 Ag. Okay, so here why we are taking 2 Ag plus? Why? Because Ag plus 1 requires only 1 electron, but copper is giving 2 electrons. If the 2 electrons we take into consideration, that 2 electrons are accepted by 2 Ag plus. So 2 Ag plus 2 electrons and giving 2 Ag. So if we cancel these 2 electrons, we are getting Cu plus 2 Ag plus gives Ce plus 2 plus 2 Ag. Okay. So here what is the answer? Cell reaction is Cu plus 2 Ag plus gives Cu plus 2 Ag. Okay, so Cu plus 2 Ag plus and Cu plus 2 Ag. Next, what is the EMF of cell? EMF of cell is electromotive force. So electromotive force of the cell is equals to E right minus E left. What is right? What is left? Right means right hand side cell, left means left hand side cell. E means electromotive force. So electromotive force of the right hand side cell, that is right hand side reduction potential. Next, left hand side anode, that is oxidation cell. So okay, so electromotive force or EMF of the right hand side half reaction minus EMF of the left hand side reaction, that is oxidation reaction. So EMF of the right hand side cell, that is reduction half reaction. EMF of the reduction half reaction and left hand side means oxidation half cell, that is EMF of the oxidation half cell. Okay, so don't confuse here, we will discuss this in the next classes. Okay, so this is about the introduction of electrochemical cell. Okay, so what is electrochemical cell and what are the galvanic cell, where we are using that and how it works and how we represent that cell representation. This is about the introduction. So we will end up this session here. We will meet in the next session. Thank you.